Hello again. In this video we're going to look at inline variables. Let's start off by reminding ourselves about inline functions. If you ask C++ programmers what they understand by an inline function, most people will probably say it's something to do with optimization. And that's true, but it's not the main point. The main reason why inline exists in the language is to get around the one definition rule. This says that a symbol can only be defined once in a program. And you probably ran into this when you were learning C++. For example, you could have a header where you have the function definition written out, and then you have some different source files which include this header. And then when you compile them together, you get an error about multiple definitions of this function. And that's because when each of these source files included the header, they each acquired this definition. So we have something like this. We have a header which defines a function. Then we have some source file which includes that header, and then we have another source code file which includes that header again. And then when we compile it, we get errors. So the function's already defined, and there are multiply defined symbols. So that doesn't work. To get around this, you can declare the function as being inline, and then you can include this header in as many source files as you want, and you don't get a compilation error. And that's because the inline keyword tells the compiler to regard this function as only being defined once. So if I change that to inline, and then now it all works. There are some useful special cases where the compiler will also assume that a function is only defined once. If you have a class definition and you write out the member function inside the class definition, then the compiler will regard that member function as being inline. It's implicitly inline. So you can include a header which has this class definition in lots of source files without getting errors about the member functions being multiply defined. And also with constexpr functions, the compiler will also regard these as only being defined once. So these are also implicitly inline. So let's check that. Here's a class definition with an inline member function, implicitly inline, and there's a constexpr function. So again, that compiles. Inline is also an optimization hint, and this is how most people seem to think of it. It's a request to the compiler to elide the function call. So instead of setting up the function call, jumping to the code which contains the function body, and then taking down the function call, the compiler will just insert the code for the function body where the function gets called. So that avoids the overhead of making the function call. However, it increases the size of the executable, and that can actually make the code run slower. So the compiler may ignore the request if it thinks it's not worth optimizing. Also, some compilers will inline functions even though you didn't ask for it. Modern compilers are generally very good at optimization, and it's very hard for humans to be able to outwit them. So the advice usually is not to bother about inline as an optimization. Having said that, there are situations where the compiler could usefully inline a function but doesn't. So in that situation, if it's really critical, for example, you have a function in a very tight loop in some code that has to run very fast, then maybe it is worth using inline as an optimization hint. Is there anything similar to inline functions for variables? C has the extern keyword, so we can have a variable which is declared as extern, and then we have source files which can include this header without getting multiple definitions. There must be one source code file and only one source code file where this variable is actually defined. So this is a bit like forward declaring a function. You can have the forward declaration in lots of different source files, but there has to be somewhere where the function is actually defined. So it works like this. We have our variable which is declared as extern in the header. We have the source file somewhere which actually defines this, so without the extern keyword and with an initializer. And then we have source files which use it. Okay. So as you can see, this is rather clumsy. An extern variable cannot be initialized. Where it's declared, it must be initialized separately. If we try to do that, then this turns into a definition and we run into the one definition rule again. We get multiple definition errors. One of the trends in C++ is to write libraries which are header only, so you can just include everything and not have to worry about source files or shared objects. So having something like this which forces you to create a source file is rather annoying. Another trend in C++ is to do as much as possible at compile time, so having things evaluated by the compiler. Extern variables cannot be constexpr because the initialization is separate from the declaration, so when the compiler sees the declaration it doesn't know how to evaluate it. So nobody actually uses extern variables as far as I know. Instead people seem to use preprocessor macros. So hash define n planets 8 and then the preprocessor will go through the code and it'll replace the token n planets by the token 8. The preprocessor is pretty horrible. There are lots of issues, things like operator precedence, multiple evaluations of side effects and so on. And C++ is gradually going through and trying to remove the preprocessor. And quite honestly, I think it should have gone years ago. But anyway. So C++ 17 now allows variables to be inline. These work just like functions. So you can define them by giving them an initial value. And then you can just include them. And there's no need to have a statement elsewhere which actually defines them. So this is how you would do it. You declare your variable as being inline with its initial value. And then you can just include that. You don't need to have some code somewhere which defines it. And there are no problems. And also inline variables can be constexpr. The compiler can see how to replace it if it just has the definition. So this has a similar effect to a macro definition, but without all the unpleasantness. And just to check that. So there it is. So the compiler can evaluate this expression n planets and replace it by the constant expression 8. Okay, so that's it for this video. I'll see you next time, but until then, keep coding.